And lastly, for problem number 45, this is our last solve the equation problem. And this time they want us to use the quadratic formula. So our quadratic formula, if you haven't had that burned into your memory by now, is negative b plus or minus the square root of b squared minus 4ac all over 2a. The most important thing about plugging things into your quadratic formula is A, make sure you follow PEMDAS to a T, and B, make sure you've got 0 on one side of your equation. We do, so we don't have to rearrange anything, but if you don't, that should be your first step. So now we can just plug everything in. Our A is going to be 1, B is 10, and C is negative 10. So we'll have x equals negative b, negative 10, plus or minus the square root of b squared, well 10 squared is 100, minus 4 times 1 times negative 10, all over 2 times 1, which is just 2. We are going to do this multiplication next. First of all, notice that you've got two negatives. Negative times a negative is a positive, so you can change those both into pluses. So we'll have negative 10 plus or minus the square root of 100 plus 4 times 1 times 10 is 400, all over 2. We continue to simplify as much as we can. 100 plus 400 is 500. But we would never want to leave the square root of 500 by itself because from problem number 29 up above, we were reminded of, oh yeah, we need to break down radicals whenever we can. So 500, we are going to break into, well, I know 25 is a factor, and 25 would be a factor, how many times? 20 times. So that tells us that's not the biggest square we can take out. It's actually going to be 5 and 100, because 100 is a perfect square, remember. So we are going to simplify the square root of 500 and call it 10 radical 5, because the 100 breaks out of jail by becoming a plain old 10. So all over 2. Lastly, we want to reduce as much as possible. Notice we can take 2 out of all 3, what I like to call pieces. So our negative 10, our 10 radical 5, and our 2. So reducing everything by 2, we will have negative 5 plus or minus 5 radical 5. That's lots of 5s. And then all over 1. So there's our final answer. Problem number 50, our instructions are the same. It's to solve, but this time we have an inequality, so we're going to solve it very differently. So when we have an inequality in one variable, we pretend for a half second that we've got an equal sign. So we'll say, okay, x squared minus 8x plus 12 equals 0. We've got a whole bunch of different ways we can solve this. We can, if we're at a loss, go for the quadratic formula. This one wouldn't be too bad to solve by completing the square, but this guy is also actually factorable. So we'll have x minus 6 and x minus 2, meaning our solutions would be positive 6 and positive 2. Now, from here, we go to our number line, and we've got 2 on the left and 6 is somewhere on the right. We are going to need to test those 3 intervals and see which interval contains my set of solutions. So it's either going to be things to the left of 2, in between 2 and 6, and or to the right of 6. So you pick 3 numbers, 1 in each of those intervals, so maybe 2, number between 2 and 6, let's go 4, why not? And then to the right of 6 we'll have 8. Again, you can pick whatever numbers you want that are in those intervals. I just went with those. Always choose 0 if you can. And then you're going to test them and see if they are true. See if they are in fact less than 0, because that's what we want. So plugging in 0, we've got 0 squared minus 8 times 0 plus 12 is less than question mark 0. Well, 0 squared is 0, minus 8 times 0 is 0. So this is saying 12 is less than 0. No way. So we are not going to shade that left-hand portion of our number line. So next we test our number in between 2 and 6. I chose 4. So we've got 4 squared minus 8 times 4 plus 12. Is that less than 0? Well, 16 minus 32 plus 12. 16 minus 32, negative 16 plus 12, negative 4. Yes, that is less than 0. So I do want to shade between 2 and 6. Lastly, we are going to test 8. And we've got 8 squared minus 8 times 8 plus 12. Is that less than 0? Well, 64 minus 64 plus 12, less than 0. No, 0 plus 12, or excuse me, yeah, 64 minus 64 would be 0. Plus 12 is 12. That is not less than 0. So we don't want to shade to the right of 8. Okay, so we're going to shade in between 2 and 6. That was the only place where our solutions existed. And since we have strictly less than, go back to your inequalities that we learned first semester. That's going to give us open dots from 2 to 6. Our final answer, we just have to write what we have now drawn on our number line as an inequality. So that's going to be from 2 to 6, and then they are both open circles, which is why we just have less than symbols in between, and our variable goes in the middle. So our final answer is 2 is less than x, which is less than 6.